Hello. Today I'm going to show you how you can get the alpha tests for the text adventure game going. I'm not going to make a full game here, but I am going to make enough of a game that I get the points from the autograder and start showing you how to approach a project incrementally. So remember, the goal here is not to sit down and make an entire game in one sitting, start to finish. You can't really approach a big software project like that. Instead, we're going to be taking things one feature at a time, and our starting point is going to be getting the points from the autograder. From there, we'll add in just a few basic game features, and that will help us start figuring out how we can build on that baseline game to add more interesting stuff, and then finalize our game. So I have here a new account, a new open version of the template that has not been filled in yet. So this is the same thing that everyone else is starting off with. We're giving you a fair amount of code, and part of the struggle here is understanding what goes into this. So we've got a few different sections. Up at the top is the header with some explanatory information. Then there's the author info section. We have our record definitions, followed by the actual core game functions, where we'll end up doing most of our work. Our win-lose paths in section 4. Section 5 will have our unit tests. Section 6 is the main game function, which is totally given to us, and we don't and should not modify. So going back up to the top, the first thing you want to do is put in your UDEL email. So I am AC Bart, and the title of my game is going to be the Dangerous Adventure. So we're making a new game entirely. And we'd write some kind of quick description of the game. Doesn't have to be very long though. A exploration of some dangerous areas. And maybe you want to write something longer or not, but the important thing is that we're starting to think about what's in our game. We're currently on version 1 of our game, and we created it back in spring 2019. We leave these unchanged. Going through the tutorial, you'll see that it starts off having you look at your record definitions, and then it has you go look at render introduction, create world, the render function, get options, and so on and so on. But that's sort of diving into things a bit fast. Real quick, let's jump down to the main function, where we see we've defined a function called main, and we have a bunch of function calls. The print render introduction call kicks everything off, calling our render introduction function and printing out some message to the user. Then we create a world stored in a world variable, and while that world's variable's status key, value, is equal to playing, then we will do the following stuff in a loop. So while we're still playing the game, keep doing this stuff over here. First, print the world rendered as a string. So we take the world, we render it as a string, and then we print that string. Then we get the available options for the world and store them in a variable called options. Then we choose a relevant option, and then finally we update the world using the command we got from choose. And if the update function returns a string, we'll print it out. We keep doing that loop over and over again until the world status is no longer playing, which can only happen as a result of the update function. And then finally we call render ending, allowing us to wrap up the game in some interesting way. So this main function is given to us, and it represents the core game engine. This is the thing that lets us play our game in practice, in the actual, when we want to release it to others. This if statement at the bottom has the function call to main. Once we put stuff into a function, we need to call it in order to actually run the commands. Now, this if statement is controlling the access from when we run it. If we didn't have this if statement, anyone who ever opens our file, who imports it or uses it, such as the autograder, would be running our game and trying to play it. But this allows us to sort of protect the execution of the game and delay it until we want it to be played. So, what else do we need to look at here? We don't need to worry too much more about the other components of this game until we get to them. So let's go back up now and start looking at our render introduction. This is the starting point of our game, and its whole job is to produce a string that introduces the player to the game. If we evaluate our code right now, having only changed a few of the settings at the top, we'll see that we don't get a very good grade, just a 2 out of 25. And there's some feedback saying, hey, your render introduction was wrong. The AutoGrader ran the render introduction function, and the result was none. But the AutoGrader wanted a string. It thought it was going to be getting a string, and everything else we can ignore for the second. Now, it wants a string and it's currently producing none, and that's correct. If we look over our render introduction function and we check out what it's currently doing, the only thing it has in it is the documentation, a string literal, and that's not returned, that's not produced by the function, that's just some data sitting inside of it. In order to pass the unit test, we must return a non-empty string. It doesn't matter what we return, as long as it is of type string and it's not empty. So literally, we can return the string banana, save the file, and run again. And right there, we just got 2 points for literally just returning some string. It really doesn't matter what we put in there. Could be orange pudding, which probably wouldn't taste very good, but it gets us a couple points the same way. We'll want to come back and make a more meaningful introduction. For now, let's leave it as basic as possible. Let's play a game. And because it's a valid non-empty string, that satisfies the AutoGrader, as we will see once it's done saving. Okay, we click Evaluate, and we should stay at 4 out of 25 points. Great, we did. So because we finished the render introduction, it passed the AutoGrader, we can see that we're getting new feedback, asking about create world. And it's the same sort of feedback we got for render introduction. Create world expects it to return a dictionary, but instead it returned none when it ran the function create world. So we're going to need to make create world produce a dictionary. Now, create world is a little bit distinct from the other functions. We have to give it a good bit of stuff. The AutoGrader knows a lot about what create world should look like compared to the other functions. The tutorial is very helpful at this point because it has us defining a few helper functions and tells us more or less what to do to get started with them. Now, the actual create world that the tutorial gives us has code that looks like this. We create a new dictionary, right? If we were just typing this bit by bit, we'd start off by returning an empty dictionary. And at this point, we could run our code, and the AutoGrader would give us some amount of feedback. Right here, it's saying, okay, I ran create world. The result was an empty dictionary. But I expected that dictionary to contain the key status. If you go back to the tutorial, you see that one of the keys they recommend is called status, and they suggest that the status's key's value should be playing initially. If we put in some typo, like for instance we capitalize the P, then it will mention, hey, I ran create world and I checked out its status key and it was playing with a capital P, but I expected it to be equal to playing with a lowercase p. So if we fix that, we can start responding to the unit tests and what they want us to do. So now it's complaining, okay, this is good. It had this, but I needed it to also contain the map. And at this point, we're going to go copy the other things that the tutorial suggests, which includes a map key and a player key, but also relies on two functions, createMap and createPlayer. If we try and run the AutoGrader at this point, we're going to get some interesting feedback. In particular, it says, traceback. This file, adventure.py, on line 75 in create world, it shows a line of code that it tried to run, line 75. It got a name error because createMap was not defined. And it also mentions, I got this error because I called create world on your behalf. CreateMap doesn't exist yet. We have to go create it. Once again, the tutorial gives us code for both create map and create player. So let's go take those and add them in as new helper functions. The convention is usually to define them prior to the function. It's actually okay to define them in either order, but you need to choose one. Now we're going to start off with a very bare bones basic game that has only one location. The initial location is going to be, we'll say, a mountain. And that means our starting location has to be a mountain. And there'll be no neighbors. And the description will be a big old mountain. And there's no stuff in the mountain. Let's take a look at this. What have I done? I have a create world function that creates a dictionary with 3 keys, one of which is create map and maps to a value produced by create map. Create map is a function that produces a dictionary, and inside that dictionary is one key, mountain, that maps to a dictionary containing 3 other keys. If you go back to our records that they give you and that we've talked about a few times, you see that everything I'm adding fits the types. Our world has 3 keys, including one called player, status, and map. Status was a string, either playing, won, quit, or lost. The map key is mapped to a dictionary with strings to locations. And indeed, my create map function is producing a appropriate thing. The mountain is a string mapped to a dictionary representing a location. Locations have the about, neighbors, and stuff. And currently, that's what we have inside of here. Everything needs to match up. It's also a good idea, while we're here, to add some documentation. So I'm going to write some pretty shoddy documentation just because we want to make this quickly. But at the very least, we should have the things it's consuming, which is nothing, and the things it returns, which is a player. The initial player, we'll say. Creates a new player. Same deal with our map. This function returns a thing that is of the same type as what we want to store in here. So we'll go and copy. Returns the initial world map. Creates a new copy of the world map initially. Okay, and our world map is pretty basic. Let's see if we manage to pass the autograder this time, satisfying it. We did! We managed to make a lot of progress. We just got another couple of points just by taking what was in the tutorial and removing stuff. Didn't even add anything, really. And at this point, we're failing a new unit test for render. So we've moved along. And at this point, the autograder's feedback is a little more sophisticated. It's saying, I ran 2 calls. First, I created a world, and then I tried to render that world and stored it in a variable called message. So rendering takes a world, produces a string. It wanted that message, the thing produced by it, to be a string, but it was currently none. In other words, it's done giving feedback on create world because we finished it, or at least a first version of it. And now it's moved us on to render. Render, once again, needs to produce a string. There's no parameters on what it needs to return besides that. So again, we could just have it return orange. Or our favorite color, or favorite fruit, or favorite breed of dog. And once again, that got us the points. We could write something a little bit more sophisticated. So let's, as a very basic thing, just write, you are playing the game. And we'll come back later and add something more interesting once we pass the rest of the unit tests. Looking at the next function we're getting feedback on, it's getOptions. This one needs to return a list. So we'll try satisfying it just by giving it an empty list. We'll find out that we do need to return a little bit more than that. Its length is supposed to be greater than 0 because you need to give the player more than at least one option. Now, the one option that everyone needs to support is the quit command. So let's add in quit. Okay. it's moving on, now trying to give us feedback on choose. Now the nice thing about the choose function is we've already written it. We had to write it for one of our earlier programming assignments, the while loop questions. So let's go take some code from there. Excuse me while I go grab a hold of it. And we will just slap it right into our game. And assuming we got the unit test passing over there, we should have a successful choose function. Let's see if it passes muster. It does. Once again, we've gone up in points, and we have done very little work so far. We have our new unit test feedback. It creates a world, gets some options, and then it tries to update the world based on the first option from getOptions. Keep in mind the trace of this execution. We create the initial world, we get the options for the initial world, and then we update that initial world based on the first option available to us. If we put some other option into getOptions as the first one, like say scale the mountain, then that's the option it would have tried to run, according to the code it showed us. So right now, assuming we stick options as getOptions as just quit, it's trying to update the world based on quit. The feedback says update needs to return a string, so let's see if we can get away with just an orange. It turns out to pass that function we can. We still don't need to worry about what it's actually doing. We're going to need to come back and update it just a little bit further, improve it just a little bit further, but for the most part, again, we don't need to do much to get those points. Going down to render ending, which is the last of our functions to implement, we have it creating the world and trying to quit the world. And it expects it to produce some kind of string representing the ending of the game. So if I quit the game, then I need to return some message, the game is over. Let's see if we can get away with that one. Great, we've got a few points for us. And now it's finally going down to actually trying to play our game. This is where the win path and lose path come into play. The feedback says, I tried your win path, but your world status ended as playing instead of won. So it tried running our game using the commands we put inside of here, our win path and our lose path. Our game is meant to be very simple. Initially, you're only going to be able to quit, win, or lose. And we're going to keep it as basic as possible. We could keep it where it's currently at and just say, oh, you can quit the game. I mean, you can enter the quit command and then the game is over. But let's actually make it so that we can win and lose. For the win path, user types in literally the word win, and for the lose path, they'll type in the word lose. Your real game's probably going to be more sophisticated. It'll be something like scale the mountain and then fight the dragon and then, hide or, slay the dragon. So whatever the story of this game is, there's a few commands you enter at the right times. But that's farther than we want to go right now. We're just trying to get basic functionality. So we'll only have it enter one command, and that'll win the game. Of course, our game doesn't support the win command yet. So we need to make sure that our update function knows how to handle this command, both the win and the lose. We'll also need to have it handle the quit command while we're here. Now, we've talked about three things here. If the command is equal to quit, it needs to do something, ... If the command was equal to win, it should do something. And if the command was equal to lose, it should do something. If it was going to quit the game, it should update the game's status to be, instead of playing, should be won. So we have a world, and it has a field called status. We can use assignment to update the value and change it to being quit. The same strategy will work for all three of these commands. We'll have won and lost correspondingly. And we'll even print out a message saying, you chose to quit. return, you won the game. I'm going to intentionally make a mistake here and forget to give a return for the lose path. I'm going to even delete the original return that I had there, so we can get to see what the feedback looks like. If we run the game at this point in time, the feedback we get says that it's trying our win path, and it thought that we were going to have an option from our get options that included win, because in our win path we said win was a valid option, and we should use it in order to advance through the win path. And sure, our update function now has logic for quit, win, and lose, but our get options doesn't. So we'll go hard code in the options for win and lose into get options. We can come back later and make it more sophisticated. We run our game again, and this time we get some interesting feedback. It mentions it tried to run our lose path, created the world, rendered it, got the options, and then tried to update the world with the string lose. But instead of doing what it thought, producing a string, it produced none. If we go check out our update function, it's pretty easy to see what happened. If the command was equal to quit, we did something and returned it. If it was equal to win, we returned a string. But if it was equal to lose, we didn't say what to return. Two options. One, have a default thing that we return. Something like unknown command, please try again. Or, alternatively, might be better to say something explicit. You lost the game. In general, you don't want your game to ever display things like, I don't know what to do now. I'm in an invalid state to the user. That's bad. You want to have a professional experience. So you should try and make sure that every one of your if statements is being handled appropriately. At this point, I run the game, and I get full points from the autograder. It's not a very good game right now. If I actually try and run it and type in some commands, then, I'm not going to be able to do anything particularly interesting. I can type in win, lose, and quit, and end the game, but it's not exactly fun. You're going to need to add more features to your game in order to pass. If you hand in this right now, you will get all the technical points for having passed the unit tests and written documentation, and once you get good code coverage, of course, currently have awful code coverage, you can get all those technical points, but you wouldn't be able to get a good grade on top of that. That's maybe, say, 50 to 70% of the project grade. But actually making the interesting parts, the fun parts of your game, that's a lot of the points still. So let's go make a better game. If we go ahead and take this file, we can start adding some features. So for instance, we could add in another location to go to. In our map, we've currently got the mountain. Let's make a peak on top of the mountain. So from the mountain, you can go to the peak, and from the peak, you can go to the mountain. The top point of the mountain. So right now, we've added a new thing. Let's try running. We can get feedback from the autograder to make sure we didn't break anything yet. Doing this habitually is really good practice. Also good practice, adding some unit tests. Sure, we're passing the autograder, but that doesn't mean that we've done what we need to do in order to make sure our game is correct. We have some design idea in mind. Clearly in my game, I should have a world with a mountain and a peak. So if I write a new test, say assert equal, for testing my world, I can write something like let's say we're testing out a map. We create a initial map variable, and we call create map, and we'll test things about this initial map. Like, for instance, I feel that there should be a mountain in the initial map, and we'll assert that that's equal to true. And also that there's a peak in our initial map. We can run our tests, and we'll find out that we have success. Both of our assertions passed. A more advanced idea is having assertions that fail. So for instance, what if I wanted to check that I had my third area, the Dragon Cave, in my initial map? I can make this test now and run the code and find out that I get a failure and say, oh, I haven't implemented the Dragon Cave. I might also have another location called the Secret Cave that's next to it. And again, this test can fail right now. That's not a problem. I'll leave it there while I add in the other features I want to have. So if they're bothering you, you can comment them out, or you can leave them in and keep making progress regardless of them. So for now, we're only focused on having the mountain and the peak, and we want to make sure that we get good code coverage. So we need to make sure that we're adding other unit tests to try out other complicated aspects of our game. If we go through, we see that we get a list of all the lines we haven't covered. For example, line 64 has not been tested, our render introduction. So let's go write an assertion that we're currently printing out what we expect. If I call assert equal using the render introduction function, I could confirm that it's currently printing out let's play a game. And because I've tested it, it disappears from my code coverage missing list, and line 64 is no longer a concern. Now, there's a lot of ways I could test this in different things. Maybe I just want to make sure that my introduction says something about playing, that the string play is in my render introduction. Using this style, I test to make sure that plain render introduction produces true. And you'll see that that should pass the unit test. There's a lot of other ways I could frame my thing. I could make sure that isIntroduction is producing a string, for instance, and other kinds of logical questions that I can ask. Testing your game is important and not something we want to ignore to the very end. The more you test along the way, the more confident you can feel when you add new features. Let's add a couple more simple features based on the tutorial. Render is currently printing out something boring. Let's make it print out the current location. In order to do that, we need to take the world and crack open the relevant field that has the player's current location. So world has a field called player. Player objects have a field called location. Let's go back here and use dictionary access to get out the player's location. And now we could just say, hey, you are in plus the player's current location. Now, how do we know if it works? Well, we can find out from the autograder that we haven't broken anything. And indeed, we haven't. But it doesn't tell us that the game is working. Instead, let's write a unit test. We have our initial map. Let's make an initial world by calling our createWorld function. And we'll assert that when we render that world, it produces a string, you are in, colon, the first location, which should be mountain, as I recall. Yes. So, we can verify that our game does what we want. And rendering the initial world gives us a string, you're in mountain. Let's add another one for after we've modified this world. Let's say that we moved our player's location over to the peak. Now when we render this world, it should tell us you are in peak. We try our unit tests and it works great. What if we'd had a typo in our unit test? Happens very easily. It doesn't need to be the same capitalization, but it does need to be the same spelling. So let's say we had a more minor mistake. Aha! Render initial world was supposed to be you are in peak, but the computed answer was you are in puke. So we need to respond to that unit test appropriately, fixing it. We've already added one extra feature to our game that makes it more interesting. Let's add another. We're going to combine the location and the adjacent places and have them both printed out. So currently, we're getting our message to be just you are in world player's location. Let's tack on a new line followed by nearby you can go to the map's other locations. So we need to do a bit of logic here, right? Based on the tutorial, you see a whole bunch of stuff where we capture the variable for the location. And then we access the world maps using the current location and get out where we are here. You might also get current location. And then you might differentiate this further by saying what we have here was the location name. So going through, I got the world player's location's current name, stored it in a variable. I create a message saying you are in location name, and then I get the world map using the current location name to get the actual current location. From there, I can get out information like the neighbors for the current location, because that's a field of any location is neighbors. Okay, we have our neighbors. We could use a for loop to add them to our message. For neighbor in neighbors. We could do various things to add it onto the string one at a time. Because remember, neighbors is a list of strings. We can't just do plus neighbors. That won't work. Because this is a string literal, and this is a list of strings, and those are different types, not supported by addition. A quick thing we can do, we just convert neighbors to a string, so a list of strings down to a string, and it won't be pretty to look at, but it will put it into a string format that we can then return. Now, we'll still be passing the unit tests unless I did something wrong. We'll start failing our own unit tests because we've changed what we think the game should do. The predict answer was originally you are in mountain, but now we have you are in mountain, new line, nearby you can go to peak. So because we've updated our game experience, we need to update these strings too. So now you can say you can see nearby, let's find out what the exact text was. Nearby you can go to, and we have to match it. At this point it may be helpful to start moving to a triple quoted string since there's multiple lines. Nearby you can go to peak. Same thing with our other unit test. You're in peak, you can go to mountain. Let's see if it likes that a bit better. Okay, we're getting another success. Nearby you can go to peak, and nearby you can go to mountain. So we've now got it rendering the things we want. It'd be a good opportunity to go take this code, load it into Thonny, and try out the game there. You know, every now and then, give the game a try. Make sure it's playing the way you want it to. For now, I'm going to keep going just a little bit farther. I want to suggest some more ideas about updating the world. Previously, I was doing get options to just return a list of string literals. I'll probably start there with having a command for quit and end up returning those. Since I'm changing my game to no longer have the win and lose functionality, for testing purposes I can leave win and lose in for now. We'll want to get rid of them after a while. But I want to start adding in options for going places. So depending on my current location, I'm supposed to be able to get to different regions. We can go copy the code that we had for accessing the neighbors of my current location. We don't need all of it. But this code right here allows us access to this neighbors variable, which has the list of the list of neighbors for the current location. And I'll add each of those neighbors in turn to my commands. Go to the given neighbor. And now I'll have a valid command available. Let's make sure that I didn't break anything when I added all that. Still getting 25 out of 25. And that's going to be the story most of the time. When I fail these tests, I should immediately try and get the game back into a minimal viable state, something I can still get points for. And I haven't done much right now besides add new get options, but I should still go write another set of unit tests. And I can assert that get options for my initial world will end up being the list quit, win, lose, and peak, or rather go to peak. Note that I didn't have a go to mountain. It should, if it's doing everything correctly, only have go to peak. Aha! I've done something wrong. Somehow, I have it going to the mountain instead of the peak. The reason for this is because my earlier unit test had me changing the location to peak. If we reorder these so that I'm trying my initial world at the right time before I change it to peak, then suddenly I pass the unit test. Your unit tests, if they're reusing variables, the order really matters if you try changing them. Remember, our updates and our assignment statements modify these dictionaries, making it a little bit harder to test. But it's critical that we take advantage of it and regularly test all of our code. I've added a few interesting features to the game. I'm still getting all of the technical points. I probably haven't gotten too many of the creativity points. If you just handed this in right now, you probably still wouldn't be happy with your grade. But hopefully now you have a better sense of where you can start adding in features and how you should iteratively design your game incrementally. The goal is never just to write a lot of features. You want to add a small thing and then write some tests that respond to it, and then regularly run the autograder and make sure that you're getting points constantly, that your game's never invalid. At any point, I should be able to walk over and have you show me your game. Now, it helps also to make sure that you're taking this and running it over in Thonny and making sure that you can actually play it and have fun. But while you're first getting it up, relying more on unit tests is a really great idea. That's all I'm going to talk about for today. Good luck, and I hope that you have success in the project's next phase.